Hello friends, welcome back to lecture number 4 of concrete technology. In this lecture, I am going to discuss design method of concrete as per IS 10262 2009 and steps for design mix concrete. First of all, there are two types of problem statements that you will face. See, as you are learning for first time in your university or other descriptive exams, the properties of all ingredients are required for design mix of concrete, and also zone of aggregate and some other properties are required. So in first case, these properties are given and you have to only design the concrete mix, but it is provided in case of your examinations. Okay, but while you have to design the concrete mix for your project work, or while you join any construction firm, then you have to first test the various ingredients as per different test procedure as per relevant IS codes, and then you can come to know what are the properties of ingredients, and then you can move towards next step, that is to design concrete mix. In this slide there are two types of problem statements. First one, in your exam or in your book you may see a question like this: design concrete mix by IS method using following data. Grade is given, then grade of cement, specific gravity and zone of aggregate, all the necessary data is given. Now in second case, in this case it is given that design M20 grade of concrete by IS code method. That much is given, no other thing. That is what will be the specific gravity, okay, what will the grade of cement, okay, you have to decide it. Now one common question, that what is the meaning of M and 20 in this M20. Now M is for mixed proportion, okay, proportion of cement, sand, that is cement, fine aggregate and coarse aggregate, okay, and 20 is the characteristic compressive strength at the age of 28 days. So always remember, this is important in case of competitive exam also, what is meaning of M and what is meaning of 20. I will discuss the importance of this topic with respect to your competitive exam also during this lecture. Now suppose you don't know what are the properties, then you have to first test the ingredient, that is cement, sand, aggregate, and these results are required for design mix of concrete. Now in this slide there are ingredients and different IS codes, so we will see one by one. For cement, we have to first check that cement is compatible or not. That is, suppose if you are using OPC 43, that it should have sufficient strength, compressive strength, specific gravity. We have to check whether it is satisfying the standards. IS 4031, different parts we have to use to check the cement, and to calculate its specific gravity we use IS 2720 part 3. See, specific gravities of all the ingredients are required for mixed proportion calculation, okay. And this IS 4031, it is required to check whether the cement is compatible or not. Okay, whether it is satisfying the standards or not. Okay, same for fine aggregates. This first list of IS code, IS 2386 383460, it is for its classification as per zone. And the second, IS 2386 part 3, it is for calculation of specific gravity. Same for coarse aggregate. Okay, first is for determining the particle size distribution, fineness modulus, and zone. And second IS code, that is part 3, it is for specific gravity. Also, we should not neglect water which we are using, because if the chloride contents are more or impurities are more, then there will be degradation of concrete and it will not satisfy its durability criteria. Okay, you may have seen cracks or white spots, okay, or spalling of concrete. It is because of water used may have some contaminants like chloride. Now IS 3025 is used to check the quality of water, and there are some guidelines given in IS 456 2000 for water. Okay, means first you have to test the quality of ingredients, cement, sand, aggregate, water, and also you have to calculate their specific gravity. Okay, means for standards you have to do tests, and also for mixed proportion you have to do some tests. Okay, particularly for mixed proportion or design mix we require specific gravity. Now next is, what are the steps for design mix concrete as per IS 10262 2009 method. First one is, we have to calculate target mean strength for mixed proportioning. Second, selection of water cement ratio. Third, selection of water content. Fourth, calculation of cementitious material content. Fifth, estimation of coarse aggregate and fine aggregate proportion. Sixth, mix calculation. And seventh, mix proportion. Now we will see one by one these steps. First step, target strength for mix proportioning. The formula is given in clause 3.2, page number 1, IS 10262 2009. Formula is FCK dash is equal to FCK plus 1.65s, where FCK dash is target mean compressive strength at the age of 28 days, which is in MPa, Newton per mm square. FCK is equal to characteristic compressive strength at age of 28 days, and S is standard deviation. All these are in Newton per mm square. Now seeing what is difference between FCK and FCK dash. Suppose you have designing for M20, then FCK will be M20, characteristic compressive strength. But you have to consider the deviation, assume standard deviation, that is 1.65s. Now this S, standard deviation, it is given in this table 1 of IS 10262. Now suppose for M20 it is 4. Now if you do the calculation, you will get FCK dash. See, FCK dash will be more than 20 MPa. Okay, because we have considered the standard deviation S. And these values of standard deviation may vary depend upon the site control. Okay, and maybe increased depending upon your results. So for these steps, it is important to know this formula. What are these terms? Three terms, and which IS code and which clause is used for this particular step. Next part is selection of water cement ratio. This ratio is specified in table number 5, page number 20 of IS 456-2000. This ratio is mainly depending on exposure condition. Okay, and this water cement ratio should be such that it should have such a sufficient durability. Oh, okay, and by your experience you will come to know what is the water cement ratio. Okay, these are the maximum limits, okay, that you should use. Free water cement ratio, okay, given over here. This is for PCC, this is for RCC. So in this slide, important points are, you have to remember the clauses, table, and these 5 exposure conditions. Okay, mild, moderate, severe, very severe, extreme. And for plain and reinforced concrete, what are the different criterias? That is minimum cement content, maximum free water cement ratio, and minimum grade of concrete that we should use. Okay, so this is the second step, selection of water cement ratio. After selecting water cement ratio, next step is selection of water content. Okay, now water content depends upon many factors. We will see one by one. So in this slide, as per clause 4.2, table 2nd, page number 2 and 3, IS 10262-2009, for angular coarse aggregate and slump value. Okay, slump value of design mix 25 to 50 mm, we can use this table number 2nd. Okay, how to use? Suppose maximum size of aggregate is 10 mm, then maximum water content we can take is 208. Okay, suppose maximum size is 20 mm, then maximum water content 186 kg. Likewise, we can use this table, but for what? For angular coarse aggregate and for slump value between 25 to 50 mm. But due to some reasons or some requirements, we cannot use these aggregates, angular aggregates or slump. We require more than 25 to 50 mm to achieve a higher workability, because it is required at site. So what we should do? Okay, so there are certain adjustment given in IS 10262-2009. What are the adjustments? Suppose for 25 to 50 mm slump value, there is no need to increase in water content. Okay, but if you want to have slump value above 50 mm, between 51 to 75 mm, you can increase water by 3%. Again for 76 to 100, 6%. Again for 101 to 125, 9%. Means it is specified that 3% increase for every 25 mm slump over 50 mm. Okay, means for each increase of slump value above 50, you have to add extra 3% of water. Okay, this is the important step or important clause. Now third point in water content, IS 10262 2009 allows use of some admixtures. Okay, you may call it as a reducer, super plasticizer. This should be used as per IS 9103, and also specifies alteration in water content in clause 4.2, page number 2 and 3 of IS 10262. Okay, now we will see in this table condition. Suppose this we have seen in previous slide, that above 50 mm per 25 mm increase, you have to add 3% more. Now suppose we don't have angular aggregates, we have these subangular aggregates, then we have to reduce the water content by 10%. Suppose again next case is we have gravel plus crushed aggregates, then again we have to use different water content, we have to vary the water content, reduce it by minus 20%. Suppose we find that our for our construction rounded aggregate, then what to do? Okay, we can reduce the water content by minus 25%. Again, suppose nowadays we are using high performance concrete, we require the admixtures such as plasticizer, super plasticizer. So in this case, suppose admixture used is plasticizer, then we may reduce the water content by minus 5 to 10%, and for super plasticizer minus 10 to 30%. So this is the clauses, or this is the important points for water content. You have to remember these things. First of all, clause, then this table is only for angular coarse aggregate and slump value 25 to 50 mm. Then there is clause which says that above 50 mm add 3% for each increment of 25 mm. Third point, that if suppose the aggregates are subangular, gravel plus crushed and rounded, and how to vary water content for admixture, plasticizer and super plasticizer. These are the important points you should remember, and these are asked in competitive exam. Next part is, after calculating water cement ratio water content, next is cementitious material content. Okay, now from table number 5, page number 20 of IS 456 2000, for desired exposure condition we get water cement ratio from table number 2, page number 3 of IS 10262 2009. We get the mixing water content. Okay, means we will see from this table we can get the water cement ratio. Suppose we are considering M20 and water cement ratio is given 0.45, and exposure condition we will consider severe. Okay, depending upon the exposure condition means your location. Okay, how the environment around your particular building, in which zone your building is located. Okay, it is a factory building in which there is a use of chemicals, or you may be situated at a coastal area, okay, that are under different exposure condition. These are exposure conditions are given in 456 2000. You may read it in. So we select minimum grade. Okay, this is for PCC. Suppose we will consider for RCC M20, water cement ratio 0.55 and minimum cement content 300 kg per meter cube. And we have also, suppose we have used maximum size as M20, sorry, 20 aggregate. Then water content will be 186, and slump we will consider 225 to 50 So likewise we have to take these values, and after selecting this water cement ratio and water content by using this formula, cement content is equal to content divided by water cement ratio. We can find out cement content. Okay, very simple formula. You have to, again, in this particular step, important points are clauses and tables and formula. You have to remember. Next is fifth stage, estimation of coarse aggregate and fine aggregate proportion. Okay, means in which proportion we have to use these aggregates. So for this, table number 3 is useful to deciding the volume of coarse aggregate per unit volume of total aggregates for different zones of fine aggregate. Okay, as we have discussed in second or third slide, we have to first determine by using IS 383 what are the zone of aggregate. Suppose we are using maximum 20 aggregate and zone is 2. Okay, then the volume of coarse aggregate will be 0.62, and then we have to deduct it from total volume so that we can get volume of fine aggregate. Okay, so approximate values of aggregates are given in this table number 3, page number 3, 1026 to 2009 for water cement ratio 0.5. Okay, this table and these values, this is for 0.5 water cement ratio, and these should be adjusted depending upon the water cement ratios which you will get while doing calculations. Okay, means suppose you get water cement ratio 0.6, 0.55, and you have to vary. Okay, next is coarse aggregate content can be varied at the rate of minus plus 0.01 for every plus or minus 0.05 change in water content, oh sorry, water cement ratio. Okay, as you may vary the value depending upon the change in water cement ratio. Okay, okay, this thing, third thing is for pumpable concrete, again these values should be reduced by 10%. Okay, mean volume of aggregate we have to reduce it by 10%. To have pumpable concrete we should have a minimum coarse aggregate. Okay, again this all things are given in IS code. Next is if coarse aggregate is non-angular one, and then what to do? Then we have to increase the volume of coarse aggregate. Okay, next thing is, now you have calculated the volume of coarse aggregate from by using this table and then doing changes by using this clause. Then how to calculate volume of fine aggregate? Simply use this formula. Volume of fine aggregate is equal to 1 minus volume of coarse aggregate. Okay, next step, mix calculation. Okay, after calculating water content, water cement ratio, cement content, then proportion of fine and coarse aggregate, next part is mix calculation. Mix calculation per unit volume of concrete is calculated as per clause 4.6, page number 3, IS 10262. In this step, we have to calculate the mass of fine aggregate and coarse aggregate. Okay, it shall be calculated. For that, you may use this formula given in certain books, in certain literatures. Formula is First formula is for coarse aggregate, and second formula is for, this is first and this is second. Okay, now see what are the different terms. V is nothing but total volume, W is mass of water of concrete, means how much water is used, shall be used. C cement content, SC specific gravity, P is ratio of coarse to total aggregate, CAFA is total mass of fine and coarse aggregate, SCSFA are specific gravities of fine and coarse aggregate. Okay, in this step, just observe, we have used specific gravities. Okay, so if it is not given in your problem statement what are the specific gravities, then you have to remember them. And in case of your project work, or while you are doing your job at site, you have to calculate this specific gravity, and for that you have to use the relevant IS codes that we have discussed in prior slides. Okay, now you will get the mass of coarse and mass of fine aggregates. Okay, there is some alternative way to find out this mass, which will which we will discuss while taking the numerical. Okay, you may use both. Okay, you may use this formula also. And important point about this slide is you have to remember this clause. Okay, and what are the different parameters that are required to calculate the mass of coarse and mass of fine aggregates. Next step, mixed proportion. Proportion of fine and coarse aggregate with respect to cement content should be calculated. Okay, we have to calculate with respect to cement content. And how it is calculated? These are calculated as following. First, consider cement as a one part of mix. Then fine aggregate is equal to mass of fine aggregate divided by mass of cement. You will get certain value. Then for coarse aggregate, mass of coarse aggregate divided by mass of cement, means you are calculating as a, or with respect to cement content. Then final mix proportion should be written as following: cement, fine aggregate, coarse aggregate. For example, you have seen like this. Okay, for M20 grade, you have seen in different books or in different literatures, that is for M20 grade it is giving 1:to 1.5:to 3. Okay, means 1 is cement, 1.5 is fine aggregate, and 3 is for coarse aggregate. In mixed proportion there are some additional points you should consider. Admixtures, if used, shall be added as a percentage of cement contents. Okay, mineral admixtures, or suppose you are using fibers, steel fibers or other type of fibers are nowadays commonly used. You have to use it as a percentage of cement content. Okay, there are actually two types of admixtures: chemical admixtures and mineral admixtures. Okay, you may use both depending upon your requirement. Second point is calculate quantity of ingredient required as per volume of concrete work. Okay, this thing you will calculate for 1 meter cube. Okay, you have to then calculate for your amount of work required at site. Okay, 20 meter cube, 10 meter cube. Okay, next is correction to water content and aggregate may be applied. Okay, there are sometimes correction because there is a variation in moisture. Okay, moisture of aggregates that are present over site, so that you can calculate the actual quantities required depending upon change in this water content and aggregate properties. Next is the calculated mix proportion of design mix shall be checked by means of trial batches. Okay, you have to check whether the mix proportion you have calculated is delivering the specified results or not. Okay, you have to cast the cubes and check the compressive strength at 28 days so that the design mix is good or not. Okay, next is again this mix shall be checked by relevant IS codes for compressive strength and workability as per 456 2000. Okay, by using relevant IS code method test methods, check whether the compressive strength is achieved and workability is achieved. Suppose after first trial, if you are not getting the result, then you have to again vary the proportion, take second trial, again test it, again third trial, until you get your desired strength and workability. Your proportion is not okay. Okay, you have to just vary the things, design, check the proportion and repeat. Okay, this is not easy. You have to have a lot of experience for having a good concrete mix designer. Okay, what the water cement ratio we should take, what are the cement content, okay, what type of admixture, what type of aggregate, it is also very important. Okay, so depending upon your experience, you will have a good hold on concrete mix design. Okay, so in this lecture regarding competitive exam also and for your knowledge also, there are some points that I would like to highlight. First is you have to remember the clauses 1026 IS code, and for IS 456 2000 also there are some clauses regarding design mix of concrete. You have to remember the steps for design mix of concrete and clauses, mainly tables and values. Next is you have to remember the IS codes for test on cement, sand. Okay, that is for required for your mix design. Okay, in many exams they have used the dash dash IS code used for testing of cement fineness. Okay, and you should also have knowledge of different tests, how to conduct the different tests. Okay, because there are tests many times used while you are interviews for your jobs, that jobs may be in private or government. Next is mix calculation. Okay, you should have a lot of practice to the mix calculation, then mix proportion. One important point I want to highlight in this lecture is revised IS 10262 2019. Okay, we are using this IS code until now 10262 2009, but it is now obsolete. We are going to use now IS 10262 2019. Okay, it is well developed with different additions important additions that are lacking in prior publication. Okay, this revised IS code 10262 2019, it is published in previous year and widely accepted and used because it has given a variety of additions, okay, that are lacking. So you may go through this IS code. It is available on BIS site. Okay, these are some references that I have referred for preparing this lecture. Thank you. If you are having any doubts, queries, please write down in comment box, and also if possible you can contact me through my email. Thank you.